Use Simpson's rule with 7 ordinates or 6 strips to find an estimate for this integral here. A curve is defined by the equation y equals 4 to the power x. The curve intersects the line y equals 8 minus 2x at a single point where x equals alpha. Show that alpha lies between 1.2 and 1.3. The equation 4 to the x equals 8 minus 2x can be rearranged into this form here. Use the iterative formula here with x1 equals 1.2 to find the values of x2 and x3, giving your answers to 3 decimal places. So let's have a look at this then. We've got Simpson's rule to start with, so I'm just going to paste in the formula. It's integral of 4 to the x between 0 and 3, 7 ordinates, or 6 strips. So let's just paste it in then. So here's the formula. Between 0 and 3 of 4 to the power x. So I'll just put it in. It is 0, b is 3. Let's put that in here. And y is equal to 4 to the x, wasn't it? Okay, so 6 strips, 7 ordinates. So we start from 0, so n will be 6. So n is 6. So I'm going to put that in for h here straight away. And we've got 3 minus 0 on top, which is 3, haven't we? So 3 over 6 is a half. So I'm going to put the half in here straight away. So it's a half over 3, which is 1/6. So let's just write that in then. And then we just need the y ordinates, don't we? So we know it goes up by half, and it goes from 0 to 3. So x0, x1, x2, x3, x4, x5, and x6. We start from 0, going up in halves, aren't we? 1, 1.5, 2, 2.5, and the last one is 3. So now we need the y ordinates. So let's just write those down. Quite a lot of ordinates in this problem. So the calculation then, 4 to the x, 4 to the 0 is 1. 4 to the half is square root of 4 is 2. And then 4 to the 1 is 4. 4 to the 3 over 2 is 2 cubed is 8. Type it in the calculator if you need to. 4 squared is 16. And then another half. We're basically timesing by 2, aren't we? All the way through. So 2.5 is 5 over 2 is 32. And cubed, 4 cubed is 64. So as we say, we're timesing by half all the way through. So I'm going to label this I. So I is equal to then 1/6. The first and the last, so that's that one and that one. So that'll be 64 plus 1 is 65, plus 4 times all the odd ones, 1, 3, and 5. So those can go together. So it's 2 plus 8 plus 32. And then 2 times all the evens in between. So that's this one and this one. And there's 2 times that, which is 4 plus 16. Write it out long-windedly so we can see the workings. So what have we got? 1/6, 65 plus 10, 42 times 4. 42 times 4 is 168. Tap it in the calculator if you need to. 20 times 2 is 40. So what have we got then? We've got 220, 220, 233, 273 over 6. 273 over 6. And it was to 3dp, wasn't it? So I'm going to tap this in the calculator to make sure I get that answer correctly. So we got 65 and 168. Let's just check that. 65 plus 168 plus 40. 273 divided by 6 equals 91 over 2, which is good. 45.5. So there's Simpson's rule to estimate this, which we've done. That's part A completed then. Okay, right, let's have a look then. Now we go back to part B. This at a single point. Show that alpha lies between 1.2 and 1.3. So if we take the difference, one will be positive and one will be negative, won't we? So let's take f of x, part B. Let's take f of x equals 4 to the power x, the difference, and it was 8 minus 2x, wasn't it, the second function. Let's have a little look at that, just to be absolutely sure. 4 to the x minus this, and we want to show it lies between 1.2 and 1.3. So here, f of 1.2 and f of 1.3, and we should hopefully see a change in sign. 4 to the 1.2 minus 8 minus 2 times 1.2 there, and here it's 4 to the 1.3 minus 8 minus 2 1.3s, isn't it? So we need to tap those in the calculator. So 4 to the power 1.2 then, down to ground level, minus bracket 8 minus 2 times 1.2, close that bracket, equals minus 0.32 and then we go and we change 1.2 to 1.3 here, and here. 0.66. Okay, that's what we've got. Then a change in sign. Change in sign. So the root lies between 1.2 and 1.3, which is what we wanted to show. So that's part B here. Okay, part 2 then, the equation can be arranged in this form. We need to use this iteration formula with these values, x1 value, to find x2 and x3. So xn plus 1 is equal to this. Okay, so this is part 2. So I'll try and write that down. Xn plus 1 is equal to, what was it? Let's just go back up and have a look. Log 8 minus 2xn ln 8 minus 2xn, and I think it was divided by log 4. Just nip back up and have a look. Log 4 here, and x1 is 1.2. x1 equals 1.2, and we need to get x2 and x3. So x2 ln of 8 minus 2x1, which is 1.2. Close bracket over ln 4, and then x3 we should be able to get from the calculator. So type this in then, ln. Now 1.2 equals, so that's in the calculator. So now we get ln, natural logarithm, bracket 8 minus 2 times answer, the 1.2, close bracket, divided by, so I've got two brackets here. I don't need two brackets. I put a bracket. It was already there. So it's 8 minus 2 times answer divided by ln of 4, close the bracket. So that should be, the answer was 1.2 we put in the calculator to start with. So when I press equals, I'll get the first answer, 1.2427. And then x3, just press equals again, and the answer will be regurgitated into the formula. 1.2316. 1.2316. And then we need to round these off. I think it was to 3 dp. There it is, to 3 decimal places, x2 and x3. So x2 will equal 3 dp 1.243. And that's to 3 decimal places. And the next one, x3, to 3 dp 1.232. And again, that's to 3 decimal places.